Hello there, Mr. Sutton here, bringing you the Algebra 2 10-3 Part 1 homework solutions on trigonometric functions of any angle. In this one, we focus specifically on figuring out all 6 trig values of various angles in a few different situations. On this problem, we're trying to find all 6 trig functions of this angle right here, given this point that the angle goes through on a circle. So let's start by identifying what they've given us. In general, we need x, y, and the radius r in order to come up with all 6 functions. We've already got x and y from this point. X is the -4 and y is the 3. To get the r, we need to use our Pythagorean theorem. So we can do the square root of x squared plus y squared, and that'll give us the r value, which is the hypotenuse of a right triangle here. So we have the square root of -4 squared plus 3 squared. That's square root of 16 plus 9, so the square root of 25, which comes out to 5. And the radius is always positive, so that is going to be a positive 5. All right, let's write our 6 functions. We'll start with sine, which in general is y over r. So specifically, we're going to have 3/5 for the sine. For cosine, we've got x over r. So that's going to be -4 over 5. For tangent, we've got y over x. So that's going to be 3 over -4, or -3/4. And then for cosecant, we just have to flip the sign to get r over y. So that's going to be just 5/3. For secant, that's going to be r over x, basically just flipping cosine. So -5 over 4. And then finally for cotan, we're flipping tangent, so x over y. Specifically then, that's going to be -4 over 3. For this problem, we're trying to find the 6 trig functions of the angle shown in this picture, which goes through the point 1, -2. So let's start by getting the radius. We've already got x and y. X is 1, y is -2. So that'll be important, but it's not the full picture of what we need for all 6 trig functions. So to get r, we have to use our Pythagorean theorem. So we can write r equals the square root of x squared plus y squared. So that's the square root of 1 squared plus -2 squared. That's 1 plus 4 in there, so that's the square root of 5, which we can't simplify any further. So we're just going to use that as is. So now writing our 6 functions, we have sine equaling y over r. So that's going to be -2 over the square root of 5. But we can simplify that by multiplying by root 5 over root 5. So this simplifies to -2 radical 5 over 5. Next up, we'll do cosine. That's x over r. We run into the same issue here. Now we have 1 over radical 5. So same trick we did up here, multiply by root 5 over itself. So this becomes radical 5 over 5. Now for tangent, we've got y over x, so -2 over 1, which we can simplify to -2. For secant, or cosecant, I'll do next, we've got basically the flip of sine. We've got r over y, so we can do radical 5 over -2, -5 radical 5 over 2, which we don't actually have to simplify because the radical's in the numerator already. Now for secant, we're flipping cosine to get r over x. So this becomes radical 5 over 1, which is just radical 5. And finally, for cotan, we can flip tangent. So this becomes an x over y situation, which means we now have a -1 over 2. On this problem, we are given the tan of an angle as -3/7, and we're told that the angle is between pi over 2 and pi. Based on that, we want the other 5 trig functions. So let's begin by identifying x, y, and r. And before we can even do that, we need to figure out if x and y are going to be positive or negative. So based off of the quadrant that we're in, this is quadrant 2 right here. This is between 90 and 180. In quadrant 2, x is negative and y is positive. We're in the upper left of the unit circle. So negative x, positive y. Now to get x and y, we can actually do that right away. Tangent is really y over x. So that means that this -3 over 7 corresponds with y over x. Since we know that x is negative, that means this negative we're seeing here must be going with the x. So this must be a negative 7. And then since y is positive, that means this has to be a positive 3. So 3 for y. Now to get the r value, we're going to use our Pythagorean theorem, x squared plus y squared equals r squared. We've already got x and y, so we just have to plug those in. So negative 7 squared plus 3 squared, and then just square root both sides. So this is going to be 49 plus 9, which is 58 inside that square root. And I don't think there's any perfect squares that go into 58 other than 1. So we can't really do much else with that other than plug it in. Let's plug these things in now. We've got x, y, and the r value. We'll start by plugging into the sine formula. So that's going to be y over r. So in this case, we've got 3 over the square root of 58. Since I have a radical in the denominator, I need to multiply by the radical to get it out of the denominator. So we have 3 root 58 over 58 for that simplified answer. Let's do cosine next. That's going to be x over r. So now we have negative 7 over radical 58, which I can simplify to negative 7 radical 58 over 58. Again, I'm just multiplying by root 58 over itself. Next up, we would do tangent, but they actually already gave that to us. It's negative 3/7. So we move on then to the reciprocal of sine, cosecant, which is r over y. So in this case, we've got radical 58 over 3, which we don't have to do anything else to simplify. Next, we'll do secant, the reciprocal of cosine, so r over x. And that's going to be radical 58 over negative 7, so negative radical 58 over 7 if we bring that negative out. And then finally, we're going to do cotan, reciprocal of tangent, so we've got x over y. And we already know the tangent is negative 3/7, so if I just flip that to negative 7/3, I've got my cotan. On this problem, they've given us the cosecant of an angle, and they're telling us that our angle's between pi and 3 pi over 2 radians. They want the other 5 trig functions. So we need to start by finding x, y, and r. And as part of that process, let's figure out if x and y are positive or negative. So based off the quadrant here, this is, let's see, 180 to 270 if I make that degrees. So this is quadrant 3. We're in the lower left of the coordinate plane. So that means both x and y are both going to be negative in that lower left quadrant. All right, so cosecant, we know that that is really, let's see here. This is the reciprocal of sine, so this is r over y as a general formula. So, and we know that the y value is going to be negative. So this negative 5/3, that means that the 3 down here, which corresponds with y, this 3 has to be negative. And we also know that r is going to be a positive, so r is going to be positive 5. So y is negative 3, r is positive 5. We still need to find x, though. So we can use our Pythagorean theorem to do that. In general, we've got x squared plus y squared equals r squared. So what I'm going to do is get this x squared by itself by subtracting the y squared over here. And then I'm going to square root both sides. And while I'm doing that, let me plug in these various things. So I'm going to have the square root of 5 squared minus, this will be negative 3 squared inside that square root. So this is 25 minus 9, which is 16. And it'll be a negative radical 16, or negative 4 if we simplify that. Again, because we said x is going to be a negative. So this is kind of the point at which we have to commit to this being a negative number. We actually could have put the negative back even further if we wanted to, but as long as it makes it on there by the end here. All right, so now we've got our values. We've got our x, our y, and our r. Let's plug all that in. So first thing we'll do is find the sine, which is y over r. So that is going to be negative 3 over 5, negative 3/5. Next we have cosine, x over r. So that's going to be negative 4 over 5. Next we have tangent, y over x. So that's going to be negative 3 over negative 4, which I can then simplify to just positive 3/4. Next, cosecant, we actually already had that. That was negative 5/3. And secant is the reciprocal of cosine, r over x. so this becomes negative 5/4. And then finally, cotan is the reciprocal of tangent, so x over y for cotan, which means this gets flipped to 4/3. On this problem, they want us to use the unit circle to evaluate the 6 trig functions for the angle 540 degrees. So in order to do this effectively, we want to put this in standard position. This is outside the range of 0 to 360, so I'm going to subtract 360 from this to get it in that magic range there. So 540 minus 360, well, let me see, 500 minus 300 is 240, 240 minus the other 60 is 180. So we do need to be able to do this without a calculator. So let me go ahead and actually graph that out to see where I am on the unit circle. So here's my unit circle. This is going in 1 in every direction here, even though I didn't label it with 1s. So 180 degrees is over here. And specifically, we're interested in the point over there. The point over there, since this is the unit circle, this is 1 left and up 0, so negative 1 comma 0. And we can use that to figure out the cosine and the sine. We'll do sine first. Sine is the y value on the unit circle, so that's going to be 0. So that's sine of theta. And then we've got cosine is going to be the x value, so negative 1. And the other 4 trig functions are just sine and cosine in various fraction-y combinations. So let's do tangent next, which is really sine over cosine. So that means we've got 0 over negative 1, which can be reduced to 0. Next, we'll do cosecant, which is the flip of sine. So this is really going to be 1 over 0, which is going to be undefined. Next, secant is the reciprocal of cosine. So we've got 1 over negative 1 for that, which I can reduce to negative 1. And then finally, we've got cotan, which is the reciprocal of tangent, or you could think of it as cosine over sine. That's how I'm going to think of it here. So that's going to be negative 1 over 0, which is going to be undefined. For this problem, they want us to find the 6 trig values of the angle pi over 2 radians. So to get this process started, I'm going to convert this to degrees just to make it a little easier to look at. So multiplying by 180 over pi, 180 divided by 2, this is 90 degrees. Let me put that on the unit circle. That's this angle right here. And specifically, we're interested in the point at which this angle hits the circle, this point right here. So that is the point 0, 1, and we know that it's a 1. Again, because this is the unit circle, we're going 1 in every direction. So based off that, I can find the sine and the cosine. Sine of the angle is just the y value here, so that's just 1. Cosine is the x value, which in this case is 0. And the other 4 trig functions just use sine and cosine in various ways. Tangent is sine over cosine. So that's going to be 1 over 0, which is going to be undefined. Cosecant is 1 over sine, so that's 1 over 1, which is just 1. And let's see, next we have secant, which is 1 over cosine. That's 1 over 0, which we know is going to be undefined. And cotan, that is going to be 1 over tangent, or you could do cosine over sine, might be a little easier for this one. They're both the same. So this is going to be 0 over 1, which comes out to 0.